5-7 minutes. So would request you to kindly bear with us for this delay.
Good morning, everyone. We'll take a little bit of an unconventional route since we are waiting for the participants, the audience to come in from the other session, uh, and which is a very interesting one on AI. So we'll wait for some more people to come in. But in the meantime, since we have all our panelists here, why don't we, uh, listen from them, their journey in the space, in the field of water, and one such person with us is Professor Ravi Gudi, who has been with IIT Mumbai for Bombay for very long, 31 years, I understand, and is part of the chemical engineering department. His work in the space of water encompasses multiple dimensions which are to do with the circular economy. But that's something which we will discuss on the panel. I would want him to talk about his journey in the field of water till we get our hall full, Professor.
Yeah, thank you. Good morning. It's a pleasure to be here with fellow participants that are very, very interested in this important theme of water. Yes, being a part of the chemical engineering department, water is central to everything that we do. But then, given that, if you look at the way industrial practices are being followed right now, there is a lot left to be desired, because everyone points an accusing finger at what chemical industries are doing. So that naturally brings us to the in focus and alignment with how do we develop chemical industries using green principles, green chemistry principles, green engineering principles. And again, as I said, water is central to all of this, because that's the important vehicle. If you look at H2O, water is also energy, because if you're able to split it and generate hydrogen and oxygen, oxygen is the oxidant and hydrogen is the fuel. And when you burn it, you get water back again. So there is such a strong circularity in the water molecule itself, uh, which points to what nature is doing. So it's very fascinating to understand the water cycle, mimic water cycle in ways that promote sustainability. And that has been the focus of my research over the last 3 decades as a professor of chemical engineering. Thank you very much.
Thanks so much, Professor. We have Vikrant here with us from Thermax. Thermax is one of the very large wastewater energy company in India. And he's had a very long stint in the space of energy compression and other parts of Thermax as an industry, and a relatively more recent awareness about water side of it more intricately. But he's just as passionate as any one of us, and the knowledge that he brings is not just what he personally has gone through, but there's a lot of organizational knowledge which he comes with. So, Vikrant, a little bit about you, not so much about what we'll discuss on the panel, but more about you.
Thank you, and good morning to everyone. Thank you, Mr. Patni, for a brief intro, and that gives me opportunity to share more about myself, my journey. I started as a GET in Thermax, and when I joined Thermax all used to be in energy and environment domain, and in any process industry, campus, we used to always say to our customers that except compressor and genset, we offer all the other utilities, where compressor, the heaters and boilers and water treatment plants and environment pollution control equipments. So what is left is compressor and engine and DG set. And then in my career journey, I got opportunity to even cover those two utilities also, a short stint with a compressor company and a genset company. So while to water technology, I am quite a recent entrant. Just a year back, I entered the water business, but I have been there in utility industry, especially in the process industry, wherever these utilities are required. I have got a fair knowledge of it, and then I've tried understanding customers' pain areas. So I think today's discussion is very interesting, because it will talk about what are the smart solutions, and I think I look forward to the discussions and the interactions with other co-panelists.
Thanks, Vikrant. We have a relatively more full audience, and therefore I think it's good time to ask Dimitra. She's from Enterprise Greece, and she is here to give us an insight into the opportunities in Greece and ask all of us to participate in the growth of Greece, in the economic journey of Greece. And I'm sure what we learn from it would be something which will inspire us to do more of that. So, Dimitra, a little bit about yourself, not so much about what we are going to discuss on the panel, but about yourself and maybe a good time, since we have at least a decent audience.
Hello, everyone. And it's a pleasure and privilege to be here in India and in this panel. I am Dimitra Anagrosopoulou. I am a legal counsel and also hold a PhD in constitutional law. I serve as a legal counsel to Enterprise Greece, the national agency mandate to promote investment in Greece and Greek exports. In the past, I have served as legal counsel to the World Bank, to the Ministry of Development, and also to the Hellenic Presidency. And it's I look forward for the discussion. Thank you very much.
Thank you, Dimitra. And thanks, Dimitra. Since we are waiting for a few more seats to get occupied, I'll ask Mishal, Dr. Mr. Mishal Laknani, who is joining us on Zoom. He is a researcher at the Texas A&M University. Mishal, I don't have a paper in front of me. I don't know whether I'm getting the names right. And he's working on a very interesting area, which is the junction on the nexus of food, energy, and water, and has a lot to offer. I had had some very brief interactions with him, but very excited to know about the addition which he'll be making to the panel. So, Mishal, a brief introduction about yourself, and again, a reminder, not something what we are going to discuss on the panel, but more about you and your journey in the water space.
Hello, everyone. Hello from Houston. My name is Mishal Ashkanani. I'm from Texas A&M University, from Biological and Agricultural Engineering, as well as the Energy Institute. My journey started with remediation of oil contamination in soil using advanced oxidation process and remote sensing. And we implemented the first AI models to optimize the removal of oil from soil, which reached 99%. Then I continued on the WEF nexus. So I looked at the interaction between water, food, energy, and now we are integrating health into the nexus dimension globally. And we see how this interaction can feed into each other and what are the trade-offs that can be translated into a language that policymakers can understand and act upon. So this is about me, and it will be a pleasure to be part of this panel.
Thanks so much, Michelle. Before we get on to the dais, a little bit about myself. I'm Ankur Patni, the Vice Chairman of Ion Exchange India Limited, which is one of the leading companies in the space of water and used water treatment. We also manufacture resins, membranes, and a lot of other parts of the chain, of the value chain, present in India and globally, and offering solutions to retail consumers and right up to municipal solutions. So across that value chain, it's my privilege to be part of the promoter group of the company. And so my family's association with the space of water has been very long. My father being associated with the company since the late 60s. So very long association in the field of water. They say that all the learnings of those early childhood years, today's water space looks very different. Yet the underlying architecture of the technology, we used to talk about Demon then, we still talk about Demon today. We talked about membranes way back in the 80s. We still continue to do that. but how these technologies have evolved is really transformational. The way that we have seen material sciences evolve, the way that we have seen the energy dimension evolve. So not going to get into that, but I'm just trying to emphasize that having a long association in the space of water, in the field of water, is not equal to understanding the current context well. And that's something which we will dwell upon during our panel. I am just equally excited as all our other panelists. We have a very diverse set of, and you've all heard about it, very, very diverse set of panelists covering views from the academia, from multiple perspectives. Professor Goody, who brings in the Indian perspective, but also has worked a lot with the government here. Mishal comes from a slightly different perspective, but very important one, as he spoke about the nexus between water, food, energy, and now health. And he is also has a strong background in data sciences, data modeling for the water space. Vikrant, of course, is an industry professional, hardcore solution provider, just like us. And Dimitra comes with a EU perspective, and she's also going to bring in the finance and a lot of opportunities for all of us to participate in. So a very diverse, very interesting panel. I'm sure that this discussion is going to be interesting. Serene, let us know when we can start.
Good noon, everyone. Thank you for joining this session. This is a very important sector and subject because as we get to know from Sir and the other esteemed speakers today, that energy, which is also very important today in the world, in the economy, that is also derived from water, and we have oil and gas transported through waterways. So water is very important. So without taking much of your time, I start this session on the smart water revolution, technology driving the circular economy. So may I now request Mr. Ankur Patni, Chairman ICC National Expert Committee on Water and Vice Chairman at Ion Exchange India Limited, to kindly give the welcome address. I would also like to request all the panelists for the next panel session to also please come up on dais. I would take your names, and please forgive me if I have not pronounced your names correctly. So I'll try as much possible. Dr. Michel Ashkanani. Okay, he has joined us online. So he is Assistant Research Scientist, Biological and Agricultural Engineering and the Energy Institute at Texas A&M University, College Station. Dr. Dimitra Agnostopoulou, Legal Counsel, Enterprise Greece. Mr. Vikrant Chitle, Business Head, Standard Plant Group Water and Waste Solutions Thermax Limited. Professor Ravindra Goody, Deputy Director, Finance, Infrastructure and Administration, Department of Chemical Engineering, IIT Bombay. So, welcome address from Dr. Ankur Patni, Mr. Ankur Patni. Over to you, sir.
Good noon, everyone, and thank you for your patience. We are delayed, but for good reasons. We had a very interesting session going next door, and obviously AI is the talk of the town, talk of the world. So we're still awaiting some of the seats to get filled up, but I think 12 noon is enough, and we will dive into the session right now. Welcome to the session, and indeed to the second day of this convention, which I think the first day was very exciting. The beginning of this second day has been very, very good, and I'm privileged to have a very, very diverse, very knowledgeable panel with me, who've just been introduced to you. So welcome to all of you. I think we've had a brief round of introductions in the chat about each one of us, but to set the context for the discussion which we are going to have on the panel, what I would like to highlight are some of the recent developments in the space of water and used water. Incidentally, we used to call it wastewater not so long back. And I was corrected by one of the ministers who were attending a session with me about a couple of years back, union minister, who said that, when will we start, or when will we stop calling it wastewater? And that was a discussion which triggered something which has now evolved, and the government, in all its recent schemes, are now talking about that effluent stream, or more in terms of used water, and something which can be reused, mined for valuable minerals, for valuable resources. And that's the paradigm shift which has taken place on one front. We are seeing that with the increasing advent of AI, which has not left any industry untouched, the kind of smartness which is now being built into our systems is absolutely at another level. Each passing month, we are seeing evolution of how the digital space is influencing this physical space in very real ways and very positive, beneficial ways. So we are going to talk about that. It's important for us to realize that the context of the entire space is almost always set by the government, because they're the ones who define the policy environment of the water and the used water industry. And government has been extremely active, proactive, in trying to bring about policies which have the vision, as they point out, 2047. But we're not used to seeing the government move so fast and move so dramatically as we have seen them do in recent times. So we have now policies from the government which look at the groundwater management, which is by policy, they are making it mandatory for the village level workers to monitor the groundwater. They are using satellites and groundwater sensors to map the aquifer levels. They are using sensors to map the level of contamination in terms of fluorine, fluorides and arsenic, and a host of other contaminants, which is something which we did not see till very recently. They are not just doing this; they have taken this entire map of the Indian groundwater basin across India, across western, eastern, central India, that we are having a complete digital picture of which basin is getting impacted from the weather patterns, how it is getting impacted. And they are trying to make the local DM aware about this almost 6 months in advance, predicting that you should expect this to happen to the groundwater if the current predictions about the weather, about the monsoons, about the usage, the crop patterns of that particular basin, they're mapping that and also making sure that this information is being made available to the people who can action upon it. That's a phenomenal change from what we were used to earlier. Likewise, when you talk about one of the much talked about schemes in the space of water, which is the Jal Jeevan Mission, and we saw that the government put in well over 2 lakh crores into funding that space, which is creating the pipeline infrastructure which enables water to be provided on the tap to rural households. They have now increased that to well over 8 lakh crores. That scheme size, whereas the government's participation has gone up by, the central government's participation has gone up by almost 1 lakh of crores. But what they have changed is, they have said that we will now link the further funding of this scheme to actual performance of the ground. We will see that the equipment which have been put are operational for a minimum of 3 months. This is for the panchayats to certify digitally and upload proof picture. They are also saying that until and unless the local teams are enabled to run that plant, we will not fund it. And each of these are now tagged, which is on a portal called Sujalam, which is a government portal which is mapping all water assets across the country. And they're not just tagging that final tap or the treatment plant, they're tagging the entire pipeline. They're tagging the reservoirs, they're tagging the state of the pumps. What is the vibration analysis of that pump? The level of smartness which they're building into that infrastructure is something which we have really not seen the government acting so proactively. And all of this data is being collected on a central platform. The visibility is not just at a village level, but at a national level. So we are building smartness into our infrastructure, but are we still there in terms of water security? The answer is no. Because the place where we were to place where we are trying to reach, where we are saying that whatever infrastructure that we have created should give people drinkable water on the tap, we're not there. We are trying to say that every drop of water which is being consumed should also be recycled. That's what the circular economy is about. That it's not just what we are consuming and then we are disposing it off, which is the linear process that we were following for ages. But how do you make it circular? How do we make sure that we treat it and we reuse it, and effectively so? So that involves not just infrastructure, that involves technology, but that also involves behavioral change, which the government is driving through village samitis, which they have created. They have mandated the use of grey water. It's mandatory now for a lot of the cities, where smart cities, as we used to call them, they are mandated that they have to reuse, they have to treat 100%, but they have to reuse at least 20% of that. And a lot of the cities in the states have, so there's a policy which is safe reuse of treated water, which the government has come up with. This is a national level framework. And a lot of the states have thereafter come out with the state level policies. After the state, the cities have come out with their policies. And this is enabling a lot of the treated water to be directed straight through pipelines to industries. So industry being the top priority, they want industry to use treated water, and thermal power plants, refineries are at the top of the list. But they also want the irrigation to use this treated water, not for the food that we eat, but the crops which are the commercial crops. They want them to use that subsoil. So the kind of intelligence that is being built in, the government machinery coming together with people like us to make sure that this does not remain a forget the apologies for that reference, but it does not remain a pipe dream, and we really achieve that goal of water security, making sure that we use more and more of this very precious resource. Don't allow even a drop to get wasted. Remember that every time that you are drawing fresh water from the ground, this is something which is disturbing the ecology in a substantial way. Many of you would have heard about the percentages that we are sitting on 4% freshwater resources and so many percentage of the world population sitting in India. But it's also about, if I use this water again, then what are the commercial advantages of it? And this is becoming more and more important as the technology evolves. The way technology has evolved to make sure that it is more efficient, to make sure that it is more energy efficient and resource efficient, is phenomenal. And the treatment of used water is being now being enriched by the fact that we are recovering a lot of resources from that used water. We are recovering, depending upon the place where that used water is coming from, but we are recovering lithium, for example. Everybody is concerned, the EV space that we are generating, where will we get lithium from? But we are recovering lithium from wastewater. We are recovering cobalt. We are recovering, in some cases, proteins, or in some cases, we are some of the process industries who are using solvents for their process. They're recovering those solvents back from the used water. So instead of being something which was wasted, it is becoming a place where they can derive a lot of value. So I read something very interesting somewhere, said it's waste till you find a use for it. So the point is not that it is waste, but it's just that you've not found the use for it as yet. And I think that is what is driving a lot of us to find technologies which help us reach that goal of treating water in such a way that it does not become a burden, a commercial or a cost burden on people, but it's something which they will value, as it is going to create a positive bottom line impact. So that's about the circularity of it. When you talk about the digital paradigm which is now affecting them, we are looking at increased presence of not just sensors, but use of things like digital twins, which enable us to provide predictive capabilities in the space of water. So we are not just being able to say that, this particular membrane system is now fouled, but we are being able to say this particular membrane system is going to get fouled 3 months later. And that's a phenomenal improvement, because it allows you to intervene at the right time and make sure that it does not fail. This is not just a question of time or a downtime, but it also reduces the cost which is there for maintenance. Ultimately, you'll be spending less if you are getting into preventive mode rather than a reactive mode. So the molecular mining, or the digital twins, or AIs, and the immense number of technologies that we are bringing in on the front of treatment is just the starting of where the smartness or the circularity is coming from. And any one of us, if we start speaking on the topic, we will end up speaking for, I think, 3-4 hours. There's such a lot of depth in this subject, but I'll not occupy the stage for too long, and we'll start our panel discussion, which I really look forward to. I'm sure that all of us will benefit from the collective wisdom on the panel. So with your permission, we will initiate that. But I do want, for the benefit of the panel and how they will respond to the questions, a raising of hands as to how many people are from the water industry. Right. And how many people would be well aware of the basic paradigms of water and circularity? Okay, great. So vast majority, but I see a good few who are relatively new to the subject. So we will accordingly make sure that our discussions cover all parts of the audience. Thanks.
Thank you, Mr. Patni, for the very insightful address on the subject. So now we come to the panel discussion, which will be moderated by Mr. Patni, Chairman ICC National Expert Committee on Water and Vice Chairman at Ion Exchange India Limited. So over to you, sir.
Thank you.
Just before Sir starts, I would like to say that the last 10 minutes of this panel discussion will be open to question and answer. So you can keep your questions ready. Thank you.
Thanks, Irene. We've got a lot of context being built already through all those introductions and this. I think I stretched myself a little bit too long, did I? So we will dive into the panel. Professor, and I would want to direct the first question to you. Since IIT has been working and we spoke about what the government is doing, but I know that the IITs have been working extensively with the government in trying to figure out a way and a mechanism to address both circularity and the smartness of it. So maybe you can shed a little bit light on the kind of work which the IITs are doing with the government.
Thank you, Mr. Patni. Good afternoon, everyone. Yes, I think if you look at some of the initiatives at the governmental level that are So we do have broadly at the national level, the National Water Mission and several other initiatives under that, the Amrut 2.0, the Jal Jeevan Mission and the like. And of course, we also have a broad mandate at the governmental level on sustainability. So if you look at that, these strategic missions are something that set objectives and goals for higher education institutes like the IITs. And IIT Bombay, we have aligned ourselves to some of these goals. We have several, in fact, let me just step back and give you a quick 30 seconds on IIT Bombay. We, of course, as you all know, are primarily an academic and research institution. But in the recent years, we have morphed ourselves to look at how to make our research more relevant. So we have what we call as a translational research center that takes our mature ideas coming out of PhD, takes them to higher technology readiness levels. Then we have a technology business incubator on campus, which we call as the SIGN, Society for Innovation and Entrepreneurship, that takes the input from the Translational Research Center and matures those ideas to basically realize commercialization opportunities. We also have a research park on campus, so the presence of corporates and their view on how the technology matures is something that helps accelerate the maturation step. It also makes the research reach a solution readiness level, if I may use. So not only technology readiness, but also solution readiness levels. And so that has begun to create significant products, services for the country at large, aligned towards nation building. But more specifically in the area of water, we have several centers of excellence. Of course, fundamental research in various departments, my own department, chemical engineering, chemistry. We have a water center, innovation center. We also have several materials research associated with water. So a lot of activities oriented towards looking at this important aspect of water. And I would like to say that broadly the focus has been, discover, develop, demonstrate, and deploy. But in these aspects of 4Ds, we are primarily looking at how do we promote the 3 Rs, which is we have water coming in at a particular quality. We have opportunities for reuse, regenerate, and recycle. So the 3 Rs. And so if you look at this entire problem of how do we promote these 3 Rs in making sustainability or promoting sustainability, you just have to stop by, pause and think of what really water is. Water is a molecule, H2O as we know, and as I just said in the preamble, it's basically also a carrier of energy because if you split water, get hydrogen and oxygen, which when oxygen as an oxidant reacts with hydrogen, you basically have water getting generated again. So it has a circularity in there. But in addition, water is really a carrier. It's a solvent or pipeline. Basically, it carries nutrients to supply, to each of our vital organs. If you industry, the water streams in the industry, it's basically water with a certain, I won't use the word contaminant level, but a certain concentration of various species that are useful at various steps of the processing, be it as a solvent, be it as a coolant, be it as a reactant. So when you're looking at this water and you're looking at, its different points in its life cycle of its usage, you want to look at making sure that you promote these 3 R's of reuse. For instance, what do we say? What do we mean by reuse? When we first use water, it comes to a particular point of a species concentration levels. Now, it's not that these levels are necessarily contaminants. It could have opportunities for reusing, maybe as a coolant, because it's not directly in contact with any other reactant. So reuse. When the contaminant level builds to a certain level, you want to make sure that you remediate it. So you bring in the step of regenerate. After you regenerate, you look at ways by which you recycle. So now, when you say recycle, recycle itself can also be recycling at various steps in the entire life cycle, depending on the contaminant levels. So what it really needs is a systemic look as to how you minimize fresh water intake, you maximize the usage of water within, let's say, a boundary. If you're looking at industrial processing, you're looking at minimizing maximizing the use of water, minimizing fresh water intake, and then being able to treat it at appropriate levels so that it comes to a point where it's fit either at an intermediate stage or at the freshwater stage, so that you can use it for different purposes within industrial ecosystem. Now, to be able to do all of this, of course, you need to know what the contaminant levels are. And to be able to do that, you need sensing. So sensing is essential. Primarily, you need to be able to build low-cost sensors that are able to sense water qualities at different points. You want to be able to build mechanisms and technologies for reuse, regenerate, and recycle. So you want to look at that aspect. And if you look at a large-scale network, water network, and industry is certainly one, but as was said by the moderator, we have a large water distribution network, let's say drinking water. Now, if you look at the scale of this and you want to monitor, you want to guard against threats, there is a module in the EPA, the Environmental Protection Agency of Water, EPA, where they say TEVA, Threat Ensemble Vulnerability Assessment. You want to be able to make sure by vulnerability, you want to keep the water quality acceptable at different points in the water network. So, distribution network, the scale at which you are operating, all of this require the bringing in of digital twins, as you mentioned, the use of AI, and you have huge amounts of data. So being able to process all of that. So sensing, being able to develop technologies for remediation, looking at large-scale data and how do you make sure you protect against vulnerability and threats, you're not vulnerable. And the fourth most important point is eco-footprint, reducing the overall eco-footprint so that you are aligned with the natural water cycle. That's what I would say as my quick initial comments on this, but maybe happy to discuss more. Thank you.
Thanks, Professor. And a very quick overview which you gave about the 3 R's and why it is relevant for us and how water plays that critical role across the chain as a solvent and multiple uses. We in the water treatment industry have lived that paradigm and more so over the last few years, where we strive to bring this into our solutions and integrate all of these into our products, not just offer one single piece of it, but an integrated solution across the chains. And more that is becoming what the customer asks. So I'm going to direct that question to Vikrant. Just like us, you have been very active in the field and trying to bring in integrated solutions So would you like to share your thoughts about how integrated water solutions are becoming an important thing to offer?
Sure. Good afternoon to everyone, and thank you, Doctor, and thank you, Ankur, for the first question. I represent Thermax, and we are celebrating our 60th year this year. If we look at our journey, this company started as in the energy space, but then backward integrated it into the environment space also. Maybe some of you may be knowing the history and how our journey has evolved. So as you said, integrated water management solutions, when we started offering the boiler solutions, we understood that a boiler will work well when the water is treated, because otherwise it will form a lot of scale inside and the energy transfer will not happen. And that's where the interest got generated. So what doctor said is that energy and water cannot be decoupled, they are integrated. And that's how our journey started in both energy domain as well as environment domain. Now coming back to the integrated energy solutions, integrated water solutions, I have a couple of cases where industry today is adopting and how they have adopted. So yes, I mean, today as a part of sustainability, every industry sets a goal and they look forward to achieving that goal year over year. So for energy sustainability, people look at how they can reduce the carbon footprint. On the water or environment sustainability point of view, they look at how they can reduce the water footprint. And as a part of water footprint reduction, I think companies like us, we try to offer the state-of-the-art solutions that we offer from our basket. When we integrated it together, from the fresh water treatment to the used water treatment, to again bring it back to reduce the overall water footprint, I think that is where this whole integrated water management solution comes in. Just a case study, PepsiCo, we worked with them. They had taken a very aggressive target of reducing their specific water consumption from 8 liters per kg of potato chips down. And I think that was an interesting journey. We studied their process, and then in the first phase, we could bring it down to 3 liters of water per kg, almost more than 50% reduction. And then the advantage with our organization is that we have other solutions like cooling solutions and heating solutions, and then water solutions. So along with our cooling division, we used the potato low vapors which get generated while frying the potatoes. We picked up those vapors, condensed them, extracted the heat out of it, generated the cooling effect. So the all packing line and the plant got the cooling solution through the waste energy, and the condensed water was used back to in the whole process. So it brought down the the water footprint even further. So today they are at least net positive is what they have experienced. So this is the journey, and I think this is what I just wanted to highlight when I say the integrated water management solutions are. Second quick example, an automotive component manufacturing industry in down south. They set up their greenfield plant a couple of years back, and during the initial discussions, and I think I'm sure you will agree that many of these solutions, if they get conceived at the beginning of the project, then the potential of bringing the circularity or bringing the recovery is very, very high, rather than doing it on a brownfield kind of a project. So we work with them. Their net fresh water usage would have been 1 million liters of water per day. And that's a humongous water, especially in the water stressed area. So we offered them solutions where we proposed them that, okay, your processed water or the used water can be brought back. And I think I'm using the term which you use. I really appreciate. Instead of calling it waste, I think let's use the used water term. So we proposed them that can we bring that water back? And I think today the 96% of their water is used back. So their fresh water demand has dropped down to only 4%. So I think this is how I think the players like us, we can play a role in this whole gamut of water management.
Absolutely, and thanks for that, Vikrant. Both our companies are increasingly, and I would say thankfully, that the customer is becoming more aware, so that a lot of the solutions that we were proposing earlier have now becoming more and more acceptable. As we try to say that, apart from all other things, reducing your energy footprint, reducing your water footprint is important. And a lot of our solutions, both our companies, are now getting oriented towards achieving those goals. One very interesting insight is to do with the sunrise industries, right? And we are all dealing with how to address the water circularity issue when it comes to things like semiconductors or data centers. And that's something on which I would like to bring in Mishal, who's been towering over all of us behind us, because he's worked extensively to understand this entire water circuits in data centers. And Mishal, may I request you to give us your insights into the water circularity in data centers and how data centers are using water and what we can do to reduce that footprint.
Okay, thank you so much. The honest answer is that most of the public conversation about data center water is looking in the wrong place. When people ask how much water a data center uses, they think about the cooling tower. And if we take an example in India, the cooling tower numbers are real. The capacity has tripled since 2020, sits at around 1.5 gigawatts today, and is heading towards 6 to 9 gigawatts by 2030. That growth is concentrated in Mumbai, Hyderabad, Chennai, Bangalore. Every one of them is already a water-stressed metro. So yes, direct cooling water matters. But the cooling tower is not where the bigger water bills lives. It lives in the power plant. India's grid is still over 80% thermal, and most of all that thermal generation is freshwater cooled. We have 40% of the plants already sit in water-stressed catchments today. So by 2030, it will be around 70%. So when a hyperscale builds a gigawatt of new compute capacity in Hyderabad or Mumbai, the indirect water bill, the water embedded in the electricity feeding it, it has several times that direct cooling number. So we can't solve this at the cooling tower. We have to solve it at the substation. So that reframe the policy question entirely. It is not how do we make data center more efficient. It is what kind of grid are we plugging them into? And the capital is moving very fast. As we see, we have Google, Microsoft, Amazon, Reliance, Adani, between them more than $50 billion committed for India infrastructure through the end of this decade. So meanwhile, only 5 of 15 state data center policy contain any sustainability parameter at all. That is the gap we are talking about. So the next 18 months of permitting decision will lock in water and carbon outcome for almost, let's say, 2 decades. Thank you.
Thanks a lot, Mishal. I think that's an important paradigm which is otherwise not very evident, that it is not about cooling the chips, it's about the power requirement, which is going to drive a lot of the water requirement. And also, we would love to hear from you the chip level cooling, because I'm sure you can shed light on that also, but I'll come back to you with that question. But as we look at and you spoke about the next 18 months and the fact that the regulatory requirement for ensuring that the sustainability KPIs are set correctly, and how we are going to ensure that in water-stressed areas, when these data centers come up, they take adequate care of what is being done to the entire freshwater resources and otherwise. The area of regulation is becoming more and more important, and it is driving a lot of our discussion in the space of water. And one of the regions which has been at the forefront when it comes to regulatory oversight has been EU. It's been driving a lot of regulations which are designed to protect the population, which are designed to protect the ecosystem. I know that they have come up with the urban wastewater reuse programs, a lot of the strictures and statutes which have been recently announced. But we would love to hear from you, Dimitra, about a broad oversight of what's happening in Greece and in Europe on this front, and maybe something about how you can help us.
Of course. Good morning, everyone, and thank you very much for this invitation. It is a privilege and a pleasure to be here in India and to join this discussion. As we have already said, I represent Enterprise Greece, which is the national agency under the supervision of the Ministry of Foreign Affairs, responsible for attracting investment in Greece and promoting Greek export abroad. In simple terms, our role is to act as a bridge. We help international investors understand the Greek market, meet the right partners, connect with public authorities, and identify investment and business opportunities. We also support Greek companies that want to expand internationally through business missions, B2B meetings, and export promotion. This is why today's discussion is very relevant for us. Water and wastewater infrastructure is becoming a very important area for Greece, for Europe, and of course, globally. So, returning to the very interesting question, I would like to point out that a strong technical solution needs also to fit the regulatory framework, the procurement rules, environmental standards, financing requirements, and expectation, of course, of the public authorities. The policy environment is becoming more supportive for investment in water and wastewater infrastructure. At European level, water is now seen as a strategic tool. It is connected with climate change, food security, digital monitoring, public health, environmental protection, and of course, economic competitiveness. The direction of EU policy is towards water resilience, better resource management, efficiency, reuse, digital monitoring, and stronger infrastructure. For Greece, this is very important because the country faces specific challenges. The issue is not only the total availability of water. The real issue is where water is available, when it is available, and how efficiently is this managed. Greece has a strong regional difference. Some areas have more rainfall and lower demand. Other areas, such as Attica, Crete, and many islands, face higher pressure from population, agriculture, industry, and tourism. Climate change is making this more difficult because rainfall is becoming less predictable and summer demands is increasing. This means that the water systems need more resilience, better planning, and better use of technology. The Greek policy responds in moving in two directions. The first direction is infrastructure investment. This includes water networks, waste matter treatment plants, desalination facilities, irrigation projects, and local infrastructure upgrades, especially in water-stressed areas. In fact, in 2026, the government in Greece approved almost 40 targeted water projects with a budget of approximately 55 million, focusing mainly on local infrastructure, upgrade, and immediate supply needs. So, the second direction is efficiency. Greece needs to reduce water losses, improve monitoring, and use water more rationally. This creates space for smart meters, sensors, data platforms, automation, and digital water management system. For investors, this policy environment is positive. It means that the sector is becoming more structured, more investment-driven, and more open to technology. Companies that can offer efficient, sustainable, and bankable solutions will have a stronger position. From a legal institutional perspective, I will also say that the early engagement is very important. Investors need to understand the regulatory framework, the procurement process, the funding structure, and of course, the role of the local authorities. They also need to understand that water projects are often long-term projects, where compliance, public interest, and operational reliability are very important. This is exactly where cooperation with local partners and support from Enterprise Greece can make a difference. And thank you very much.
Thank you very much, Dimitra. That was quite exhaustive and very useful for all of us. It does show that there is so much opportunity which is coming up in EU, and not just Greece, but entire EU
Absolutely.
platform. And we know that EU is increasingly focusing on the forever chemicals. We know that they're focusing on contamination coming from cosmetics and pharmaceuticals. These are some of the evolving areas, and they are now mandating that advanced oxidation is a part of all schemes. And they are looking at decentralized sewage treatment infrastructure for sewage treatment, but also other effluents. So a lot of opportunities coming in for companies like us, which have the solutions for all of this. Both of us, we manufacture resins, we manufacture membranes, but also have the right execution capabilities to ensure that we can help in this entire process. But what was interesting in what she said is also that the entire EU infrastructure is now gearing up for smart sensors and smart metering. And that's an area which you mentioned that you've worked on, and with 5 specific use cases in the EU. So maybe you can shed a little bit light on that.
Yeah, thank you. Just wanted to highlight an important project that IIT Bombay and IIT Guwahati on the India side worked with the European Union side, 3 universities there, University of Dortmund, University of Exeter in the UK, and CNRS in France. And the focus, as I was mentioning in my earlier preamble, was to develop a low-cost intensified sensor, because that is central to everything that you do in digital water infrastructure. You need to be able to sense quality at different points in the life cycle of water usage. So low-cost water sensor, low-cost, high-quality water sensor. We laid our bets on carbon nanotubes, which are functionalized with certain specific types of polymer inks that are sensitive to different contaminants. For example, if you want to sense arsenic, if you want to sense fluoride, if you want to sense lead, different types of contaminants in water, you have a carbon nanotube that's functionalized with that specific type of a polymer ink that needs to be discovered, of course. But once we have that, it can directly be immersed into a water stream, and it develops an electric potential which can be calibrated to different levels of the contaminants. So we developed a low-cost intensified water quality sensor that can sense about 13 to 14 different types of water contaminants, but actually species. Let's not call them as contaminants, water species. Basically, starting with arsenic, lead, fluorides. You can also extend it to pH, temperature, nitrate, nitrites, chlorine, and chlorides. So you could look at all of these. And the advantage of doing this is that because it's of the size of half a palm, it is basically containing carbon nanotube structures arranged along an array, and which, when dipped into a water quality stream, it can generate signals that can be interpreted, calibrated to sense and display different types of contaminant species levels. This is something that we did, but in addition to that, we looked at 5 different water use case scenarios. First is, of course, primarily to what we all as a human population need, which is drinking water. So you could look at drinking water through networks, through, let's say, tankers, especially in urban areas in India. Bangalore, for example, where water is still supplied through tankers. And of course, medical hospitals that need ultra pure water. So use case scenarios on water for domestic use and hospital use. The second is surface water, for example, the Namami Ganga project and looking at the surface water related aspects. The groundwater, increasingly this is becoming important because as we become more and more intensified in terms of fertilizer use, you are basically looking at the percolation of the fertilizer, the chemical fertilizers going down and the groundwater. So groundwater needs to be geotagged. Its quality needs to be monitored. So drinking water, surface water, groundwater, wastewater is the other important aspect. I mean, in the industry, there is I was just mentioning to Deepa that there is a wide diversity of quality of water that we kind of discharge depending on different industries, but also at different stages of processing. And that needs to be sensed. So how do you develop low-cost sensors that can sense those species? So the four of I mentioned drinking water, groundwater, surface water, wastewater. And the fifth one, most important, is the agricultural water. So the 5 use case scenarios, be able to sense water quality and then generate the necessary balance of the systems that exploit the data generated from all of these sensors and make use of them to promote the 3 R's, which is recycle, reuse, and regeneration. I would just like to highlight one important use case, which is in industrial waters, the steel industry. The steel industry is a water guzzler. It uses direct contact as well as non-direct contact water. Now, if you look at direct contact water, it quickly generates water that's not of acceptable quality with a high load of contaminants. But if you look at non-direct contact water usage in the steel industry, it is not its discharge. At the end of the processing of non-direct contact cooling, you basically generate water that is relatively of a lower contaminant level. Now, there is an opportunity for reuse of that water within a steel industry because its contaminant level is not as high, but with the direct contact cooling, there is the contaminant loads that are high. So if you look at these two different types of water quality within a steel industry, there are opportunities to do recycle, reuse, regeneration. And we were able to demonstrate for one of the steel industries that we were able to reduce the fresh water intake through promoting recycle, reuse, and regeneration. We were able to reduce the fresh water usage to the extent of 35%. So there are a lot of opportunities like this, be it in the pharma processing, be it in the dye industry, be it in the petroleum processing industry, sour water stripping and things like that, where there are huge opportunities to maximize the 3 R's through sensing, bringing in a systemic view. And the systemic view gets a little bit into mathematical modeling of the water flows, the transport of water, being able to monitor their contaminant levels, being able to develop, recycle. So that would mean retrofitting in terms of additional recycle infrastructure, pipings and the like. But as mentioned by Vikrant, if this is done at the green project stage, this is right now already becoming green in terms of how you promote these recycles. So if you are able to do that through sensing, through 3 R's, and then rerouting the water to maximize the amount of, minimize the amount of fresh water, maximize the use of water within envelope or the battery limits of a plant, there is a huge opportunity to basically promote sustainability, minimize, I would say, see that there is also a cost associated with being green. There's a cost associated with treatment of water. So if you really make sure that you understand to what quality you need to treat the water, you don't have to always treat it to ultra pure quality. You can always treat the water to a certain quality that's acceptable at a different point of usage within the battery limit. So if you're able to do that and exploit these opportunities for lowering the cost, it can actually become very green, as was demonstrated for the steel industry use case. So I would say that, we need to maximize the use of systems engineering approaches and the opportunities for making effective use of the data that we generate. And as the problem becomes large, that's where AI steps in. There is a lot of AI. Why is AI useful? Because it addresses uncertainty, it does faster, cheaper, better, and it addresses problems at scale. What can be larger than a water distribution network in a city like Mumbai? You want to make sure that you exploit the power of AI through digital twins, make sure that you understand and get acceptable drinking water quality at the taps for various aspects of industrial use. And, I would just say that while we do all of this, we need to look at nature, because nature is the best teacher, I would say. Nature would always preserve its ability to nurture us. So we need to understand and see, what does nature do in terms of bioremediation. There are mangroves, which is a bioremediation. You have natural bioremediation of water happening through the water cycle, when water gets evaporated and comes down as rain. There is soil which can actually remediate water. In fact, some of the soil biotechnology, the largest project increasingly being deployed in the city of Mumbai, in the municipal corporation at Devanar, is a soil biotechnology kind of a solution, where different qualities of soil is being used to remediate water. So wastewater is percolated through this I would say, bed of soil that is specifically empowered with certain microorganisms. So as the water percolates down, it gets remedied and you get acceptable water quality, or at least water that can be used for horticulture. So you need to learn from nature, you need to biomimic nature and look for opportunities where we can support the bioremediation aspects of nature to be able to develop low-cost technologies that are effective for circularity. Thank you.
Thanks a lot, Professor. I think the kind of work that we are all doing in a very difficult circumstance, where we are retrofitting in a city, and that also a city like Mumbai, it's a massive exercise. And as you rightly pointed out, doing any retrofit is so much more difficult than coming out upfront with a solution. And I think in the industry today, for example, we are putting solutions which are digital first, putting the sensors in right at the time when we're offering the solution. And across multiple, you mentioned about the steel industry. So across multiple water circuits within that steel industry, we are trying to trap all of that information on a single dashboard. And that dashboard is not just for one industry, but across multiple customers, which is giving us so much insight into what's going on much before the problem is triggered. So, both with respect to how digital first or circularity first solutions are important, and also to get a perspective of the entire water circuit rather than bits and pieces of it. I think very important. But I want to bring in Vikrant on that because we were discussing earlier about how we need to make sure that this smartness is built in upfront. And as an industry, I think we have a role to play in making this happen in a much more. It helps the entire water resources of the country, de-stressing from an industrial perspective. So your thoughts on that?
Sure, thank you. So here, before getting into the water as a utility, I would like to just share the experience of all the utilities which are used by industry and the industry customers' perspective about the overall utilities. Say, take a case of a food beverage manufacturer. His business is to manufacture beverage, and he is forced to set up utilities like boiler or heater or a water treatment plant or a effluent treatment plant, and that's not their core area. Their core area is to treat their raw material, process it, and then give the output. So many of these utilities actually form a substantial component of cost in their overall cost structure. And that's where the increased awareness that how can I reduce my specific utility consumption per my product. Now, this is true for energy utilities as well as the environment utilities. So this word which I have interpreted in two ways. I mean, so is the industry. Like smart means this specific, measurable, achievable, relevant, time bound is what we call it as. But now the other meaning of smart is like it is coupled with the AI, some smart digital solutions, some smart sensorization. And I think that's where we have seen that these solutions, primarily are based on a very strong foundation of sensors. That's what I think doctor said, and I think that's true, because any wrong signal coming is like junk in, and then your output will also be junk. So monitoring and measuring the parameters smartly and correctly, accurately, with a very good sensorization is a very fundamental base. On top of it, then the further analysis, prognostics, all that comes. So in water solutions, what we have seen is that it is very chemical dominant kind of a treatment, whether it is fresh water or used water. So we have introduced chemical management tools backed up with AI and ML. In a rudimentary system, an operator will operate the plant. He will set up the dosing once in a while as per the OEM guidelines. And then it could be excessive dosing or a less dosing compared to what is required. And that's where the whole process gets into overuse or underuse of the dosage or chemicals. So the smart solutions, what it does is that it plots a graph continuous basis, that taking feedback from the sensors and then ensures that the dosage happens in line with the plotted graph. And that's how the chemical managers operate. All water and used water treatments are also very biology dependent. So while managing chemicals was easier, how to manage the biological treatments with the same smart solutions. So we recently introduced a bio health monitor, which monitors the health of the effluent water, and then accordingly we can set the parameters, especially the I would say the dissolved oxygen levels and all, some technical terms here, but dissolved oxygen levels, and then trimming down the airflow, etc. So this is how I think these smart solutions, especially in water, we have seen that fundamental base of sensors, then chemical manager, and then biological health managers. This gives a fair basis of how the output is very close to what you are intending to. And the another important part of any utility solutions, may it be water or used water or any for that matter compressor engines or heaters, boilers, is that it's a marriage with the plant for a fairly long tenure. It's like 15-20 years of life of a utility equipment. So while the capital intensive nature of those equipment is one side, throughout the life cycle, it also consumes a lot of operating, spares or consumables. So it's very OPEX and CAPEX sensitive kind of a proposition. And on top of that, the customer says that I am forced to use this. I am not in the business of it. So, I mean, can I not get rid of it? So considering this fact that the goal when we offer a smart solution, goal for companies like us is how we can reduce the life cycle cost for the customer, because ultimately all the utilities he will use will sit in his typical cost sheet as a indirect cost, and he will try to see that if I can get rid of it, I think that will be the best thing. So nowadays, I mean, I would say there are utilities on higher kind of solutions also, or utility you pay per utilization. Those industry solutions are also available. But I think ultimately the goal is that customers should adopt it, because it is to do with the sustainability and ensuring that the usage of resources is used as less as possible, because it's our duty as a citizen, as a industry fraternity, to keep the earth green, sustain the blue, and give it back to the society, because we have used it, and I think the future generations also need to have something to be used, and in a fairly nice way and healthy way for leading their life. So that's what I think the whole value proposition is. Now, the next part of your question was that how do we adopt it? I mean, how do we encourage the industry to adopt it? So my perspective, and this is true with all the utilities, that the top of the customer pyramid is very sensitive about it. All evolved MNCs, all big size conglomerates, they are very, very committed to the sustainability goals. Now, how do we take it to the mid of the pyramid and bottom of the pyramid? I think in India itself, if we look at the data, I think there are multiple lakhs of industry and entrepreneurs in that bottom of the pyramid. Now, they are very cost sensitive. And then that cost sensitivity is what I think becomes sometimes the deterrent in terms of adopting such smart solutions. So maybe I think some research, some homegrown research with academia might help us, bringing the capital operating cost down and making the products or the solutions acceptable to even the bottom of the pyramid. I think that should be the goal in at least domestic market. So is the case with international market. Yeah.
I think very, very right, Vikrant. More and more when we discuss with customers, the thing which we talk about is total cost of ownership across the life cycle. And that is something which is now the customers are accepting more and more. When we show them that dashboard, which says that everything is in control, and if there is even one parameter which goes out of line, you will get a flash, you will get an alert. So even when we are doing the entire operation management, we have taken the boot contract. So he is now sure that this company is taking care of all my utilities, is not my headache. Even then, we are showing to them that, look, this is how your graph looks. Even if there is one parameter out of line, you will get to know. The alerts will come to him. And progressively, every time we are showing to him that, look, your chemical consumption is going down. Look, your energy consumption is going down. The smartness which is coming, as you rightly said, putting in the right sensors up, making sure that the digital solutions are available not as an afterthought, is something which is really helping. And I think as an industry, we owe it not just to the future generations, but the current crop of industries and business owners, to make sure that they see that value immediately, and the environment benefits from it simultaneously. So very, very important that we together do this. Another dimension which I want to bring about, we are talking about industry, we are talking about the life cycle costs, the way that the water, energy cycle, the nexus is deeply interconnected with food and health, is very important when you look at it from a national perspective. And more we are seeing that the usage of water is going to first go for human consumption. That's like the top of the mind priority. But we also know that the largest consumer is irrigation. It's going into the agricultural sector. So we can't ignore this. Industry actually comes below this, which is why industry is now being forced that you use the treated used water. So to bring that dimension in, and I know that Mishal has worked quite a lot on this field, has got a lot of insight into how this food, energy, water, and health nexus works. So Mishal, over to you. I think we will want you to throw a lot of light on this nexus and how do we handle circularity in the best way.
Okay, thank you. So I want to be direct about this because I think it matters. So water positive as a corroborate claim has often been an accounting exercise, not a hydrological one. A company can take water from a stressed basin and fund a wetland project somewhere else and call that water positive. From the perspective of the community that lost the water, nothing has been replaced. From Nexus perspective, that is offset, not circularity. So genuine circularity to me means the same molecule of water in the same basin doing more work before it leaves. That gives you a simple test. So we have three pillars here. First, what goes in should not be drinking water. For example, we have Singapore made this decision 20 years ago with new water project, and reclaimed water now meets close to 40% of national demand and feed heavily industry at lower cost than portable supply. India has already done that at the treatment capacity in cities like Bangalore. The missing piece is the policy default. A new data center should not be permitted to draw portable water for cooling unless they prove they anything else. So second, what comes out should be useful to someone. We have Amazon facility in Umatilla, Oregon in the US, where they pipe almost all their cooling water to a neighboring irrigation district that uses it on 10,000 acres of farmland. That is replenishment in the same basin, doing the real work. And that is the model India can replicate, because most of our data center cluster sit in or near the irrigation commands. Third, we have waste heat that shouldn't just go up the chimney. At tropical climates, we have low-grade heat has industrial value. India has barely started here. So what should any country model on specifically is like we have here in India, Naya Raipur, which is India's first AI data center park, launched last May. So it's the natural place to mandate all the three pillars by day one, before bad design gets locked in. So Andhra Pradesh has already done something quietly important by promoting seawater cooling from Visha Kabatar Namcost, and Rajasthan new policy ties incentive to green data center tag. We have the conditionally is what matters that needs to become national. So the honest reason this matter now is that when a journalist go and ask any operator how much water they used last year, the answer is inconsistent and in some cases simply absent. So without facility level disclosure, Silk Road is just a marketing word. But here where I want to draw some attention, we have water is connected to energy. We need water to cool down energy, and we need energy to pump water, and all this feeds into the land where we have agriculture sits. So if we don't put in consideration one of these dimensions along with the other dimension, what will happen is a complete fail of solutions, complete fail of promoting suggestions for the government. So can policymakers suggest policies to control this dimension and reach environmental sustainability? Thank you.
Thanks a lot, Michelle. I think this is something which obviously the government is thinking about, but very rightly the policy advocacy has to be done, and this is the right time for it to ensure that none of these forward-looking initiatives in the front of AI or data centers end up causing ecological or environmental disturbance. You rightly said that a lot of these data centers are coming along the coast, and seawater is going to be used, and that's a step in the right direction. There is also talk of treated used water being used for data centers to a large extent. So I think the direction is right, but we still need to be very aware of the implications of all of this. So before we end, I'm going to, because we've reached 1:15, I think there's so much more that we can keep discussing on this subject, and I'm sure some of people in the audience would want to raise questions and have a word with us. Before we take those questions, the one thought which I would like to get from Dimitra, she spoke about the opportunities coming in EU. A lot of us are interested in those opportunities. How do we make sure that through Enterprise Greece, we can make the most of those opportunities in the space of water and wastewater? How would you be able to help us get into that market. And as Mishal said, he's visiting Greece, and you have offered to help him. So how do we make sure that we get the right help from you?
Of course. First of all, I would like to point out that there are several interesting opportunities for Indian companies in Greece water and wastewater sector. The first opportunity is the modernization of the water infrastructure. The second opportunity is, of course, wastewater treatment and water reuse. The third opportunity is desalination, especially for island and coastal areas. And of course, we have opportunity in irrigation and agricultural efficiency. So, how Enterprise Greece can facilitate this Indian participation in Greek business environment? As I mentioned before, our role is to act as a bridge between international investment, the Greek public sector, and the local business ecosystem. We are not only promoting Greece as an investment destination, we also help companies understand how the market works and how they can participate in real projects. Our mandate goes beyond promotion, including active facilitation of investment, coordination across public authorities, and support through the full investment lifecycle. This includes project identification, stakeholder alignment, licensing facilitation, and ongoing support during implementation. First, we can help companies understand the opportunity pipeline. In the water sector, projects may come through public tenders, PPP schemes, municipal project, utility investment plan, or EU-funded programs. For a foreign company, it is not always easy to understand which route is the most relevant. Enterprise Greece can help companies understand the different entry options, the general requirements of the market, and the stakeholder involved. Second, we support stakeholder coordination. Water projects are usually complex. They may involve ministries, as I said, municipalities, water utilities, regulators, financing bodies, and private companies. For an international company, entering a new market for the first time can be very challenging to navigate. So, Enterprise Greece can help investors identify the right stakeholders and make the first connection. This is important because early communication often helps companies prepare better proposals and avoid, of course, misunderstanding later in the process. Third, we support matchmaking with Greek companies. This is very important because many water projects require local partners, and Indian companies may bring technology, financing, equipment, or large-scale project expertise. Greek companies, however, can bring local market knowledge, engineering experience, project execution capability, and understanding of the regulatory environment. Through B2B meetings and target introduction, Enterprise Greece can help companies find the right partners and explore possible cooperation models, such as a joint venture, consortia, subcontracting, or technology partnership. Fourth, Enterprise Greece can support investors during the implementation phase. This includes guidance on licensing, public administration procedure, site-related questions, and communication with relevant authorities. Of course, Enterprise Greece does not replace the competent authorities or the legal advisor of an investor, but we can help facilitate communication and keep the project moving. Finally, we will support the international dimension. We support Greek companies that want to expand abroad and can also help create partnership between Greek and Indian companies for projects outside Greece. So our message to Indian companies is very simple. Come early, understand the project pipeline, find the right local partner, and in this context, Enterprise Greece can serve as a facilitator to navigate the market. And of course, if you need any more information, we are very happy to provide you, and you can contact us via mail or now in the lobby. Thank you very much.
Thank you so much, Dimitra. I'm sure a lot of us will try to take advantage of those opportunities. Now, with the permission of all the panelists, unless you want to have some last word, we can request for 2 or 3 questions from the audience, and then we can conclude. Can someone give a mic to him? Yeah. You can give this one.
Okay. I think I'm audible.
Audible to us, yes.
Have we lost Mr.?
No, he's there.
My name is Vishwas Tendulkar. I represent International Center for Clean Water. This is the IIT Madras initiative funded by T. Pollock Foundation. We work only on clean technology for industry, agriculture, and individual. My question is, India is a water-rich country. The statement is very bold. We get 3,000 mm of water average across country. No other country in the world gets 96 days of rainfall. India is the only country. The issue is not with the contamination. The major issue is the consumption. My folks in rural India and Mumbai are not getting water because the consumption is not monitored. I do not know how much water is wasted by me also. Now here comes the smart metering. The word smart should be controlling rather than measuring the smart. How much water I need, as and when I need, is something which is important. I would like to highlight here, Government of India has smart meter for electricity, which has been rejected outright because it is not measuring, not giving the benefit to the consumption. I worked in different countries. In US, $1 I put it, one flush is $1. Same thing for the which is if that smart metering helping the water consumption, then it is going to be a healthy situation. Somebody is taking the a shower bottle, somebody is taking the I know water. This is something somebody is taking the shower 3 times. I do not know. For the individual, it is charged not on the consumption basis, charged per capita 165 liters. 45 liters for the my drainage consumption, which is more. My washing machine consumes 165 liters of water. How about that? That should be smart metering, not the other way. It should beneficiary, all the 3 benefits should get benefit. We are working on it. At Chennai, we are working on the same thing. Shortly, we are giving solutions. And for the individual, we'll come out with the smart meter. We've also worked with the government. Thank you very much.
Thank you. We look forward to the solution coming out. But I dare say that the government has tried to bring in measures at village level and at DMA levels to monitor both the water which is coming in, which is getting consumed, and which is getting recharged. And they're incentivizing states and villages based on that recharge quantity. So this is being actively worked upon. And advanced metering is something which is already happening. In fact, there are meters available which will be able to track whether you have, it's on the meter level. They'll be able to track whether you have taken a shower or you have just filled up a tub of water. So it has to, so it's under implementation in some parts of the world. So I think the technology is coming and you're very right in pointing it out. Professor, you want to share some thoughts on that?
On the consumption, smart protection on the consumption. The contamination is the next thing, serious. Main thing is the consumption. Somebody is getting more, somebody is not getting more.
Yeah. So
What is to get a right is the constitutional right, but
Yeah.
we don't have anything on it.
yeah, all that I can say is that responsible usage is what must be promoted. Smart meters can come in. Responsible usage, for example, we all are sensitized to first, second, third use of plastic. Why can't we have a similar thing for water? First use of water, second use of water in terms of horticulture, third use of water, treat it to a certain point and then discharge it. We can do these things. I think responsible water usage will make sure that our aquifers or reservoirs are sufficiently full. The other important thing is, although we receive a huge amount of rainfall and nature has been very kind to us, we are not accepting the kindness with gratitude. We are faithfully channeling all that water back to the sea. We want to make sure that we also adopt ways by which you can store the water for usage for a wider community. That would be my 2 comments.
Plastic usage has been channelized after EPR, not before that. So
Can I? Yeah.
We'll just take 2 more questions
Wow.
before we close the session.
I'm the former director. I'm Dr. Nayak, former Director General under Department of Chemicals and Petrochemicals. I was heading an institute called Central Institute of Petrochemical, which has a pan-India presence. So very interesting session. We talk about sustainability, we talk about EPR, we talk about circular economy, linear economy, beginning of life, end of life. My concern is because I'm chairing the BIS standard committees and I'm also the chairman for the expert committee for drinking water packaging. I'll start with this. Now you all know, he talked about EPR. Now the Gazette notification says each PET bottle will have minimum 40% of recyclate. Now when I say recyclate, it is food contact grade. It's not food grade. Food contact means it goes for overall migration and specific migrations. The standards and SOPs are getting ready and every bottle has to be seen, particularly the feedstock which is coming has to be passed through the challenge test and it has to go through. Similarly, when you talk about pipes, it's PVC pipes, ASTM 1785, IS 4985, HDP pipe, IS 7325, IS 4984, IS 12818, all the standards we have done. But the challenge is recyclate. We do not have any Indian standard for recycled materials because you cannot go on using the properties goes down. The professor is here, you'll understand. So where do we check? Not talking about 30% mixing. The fossil-based material, you know, waste is here, where everybody is using recyclate. So when you do recyclate and you have a lot of stabilizers, PVC stabilizer with lead stabilizer, arsenic, all those materials comes out, the water gets contaminated because of drinking water. So such a session, particular to Mr. Patni and Professor Goody, I will request BIS must be approached to create standards for recycled material. And let's not say it's recycle, it's upcycling. Unless we do upcycling, the food contact, which is the very challenging, which you told, for drinking water, whether it is, these are absolutely goes to our body. So this is what I just will advise. And as regards to one more thing, the beginning of life and end of life, that has to be really looked into. You cannot go on recycling. It has to go back to its original. So circularity will be there. If you do a mechanical recycling, you don't get an end of life. But if you go for a chemical recycling, if you go for a physical recycling, I think that is where we should work more. And IIT Mumbai is doing good job. Probably they can join with CPET and do wonderful job, which goes to BIS, industry is benefited. Thank you.
Thank you.
Thank you very much.
Just one more question, please.
You want something?
Yes, lady in front of me.
Yeah.
Can we have a question from her?
Nothing. No, that symbol is not for that. Each symbol is
somebody please
about
pass on the
material.
mic
7
here.
is for recycle. 1 is for PE. 2 for PVC. 3rd for, that's not for recycle. It can be the material's
You
identity.
can come here and ask the question if that's not working.
My name is Sanskriti. I represent Evidence Action, AI Advisors. We work in rural and underserved areas of India, delivering safe water at the last mile using fluorination technologies. So, sir, Mr. Patni, you talked about scaling Jal Jeevan Mission, infrastructure, grey water reuse, and village water committees. But what we see on the ground today is many villages are still struggling even with basic O&M and governance structures. Device operators remain overworked, underpaid. Much of the water infrastructure remains outdated. Fluorination technology is installed but not operational. And many village water committees are practically defunct. Most of them that Jal Jeevan Mission talks about. I also want to add that the unfortunate incident that happened in Indore, there is reason to believe that people were already complaining about the water color and the water smell, which a sensor or IoT would have also done to the authorities. Right? In light of all of this and in this context, my question is, are we really overestimating what technology and AI can solve for us? Is the bigger gap actually long-term institutional capacity, accountability and ownership beyond these pilot projects and CSR? Obviously, it's very exciting to hear about smart water, but what about the underserved communities of India?
I'll want Professor to jump in on this, but before that, let me tell you that the problem which you pointed out is very real. We know that the central government at one point of time last year categorically came down on the fact that a lot of the projects were being reported as complete, but on the ground the completion was not visible. They have started to tag digitally, and for each village, for each facility, now they have a tag available centrally on the Sujalam portal. And there they are not just tracking the fact that the problem exists, they're also tracking the fact that whether this has been operational. They're tracking chlorine levels, they're tracking the levels of water in the storage tank, they're tracking the flow of water in the pipes, they're tracking the pump performance. So for someone to fool the system on a consistent basis will become more and more difficult. The idea is not just to say that there is digital and will take care, but to provide enough information in the hands of the people who are monitoring to flag the alerts enough so that we are being able to rectify it. Ultimately, the users have been empowered through a portal to see what is happening. And if they are the ones who will get benefited, the actions will happen from there. But it's a journey. I don't think it is something which will happen, at a sharp cut. But Professor, maybe you can jump on.
Yeah, I mean, I would say that, you develop technologies, you make them as smart as you can, but eventually the proof of the pudding is what kind of impact it creates. And to be able to do this, of course, there has to be management that exploits the technology developed for creating that impact, for monitoring that impact. And geotagging, for example, suddenly if because of aquifer flows happening underground, you have at certain points you have unacceptable water quality. Sensing that, geotagging that, and being able to send that in a cloud will make sure that you develop the necessary alerts for people to basically take note of it and not use that source of water. So I think these advances are more to do with IT enablement of the data that's generated through these sensors, and a lot should happen in that area. See, let's not push back on developing technologies. Let's push forth on making sure that we proliferate this technology, percolate this. And I would say that across these three areas of what the nation is doing, strategic, operational, as well as the last mile societal impact, which is our Honorable Prime Minister, Sabka Saath, Sabka Vikas, we want to make sure that the technologies, especially low-cost sensing, low-cost assessment, analysis, and low-cost awareness of how this water quality is being delivered at your doorstep or at the tap is something that one must develop. But, I think you highlight a very important social aspect of it, but technology can solve it in conjunction with management, and the very important point that Dimitra made, but effective policies to make sure that we deploy this technology for creating that impact. That would be my response to it.
Rest of the questions we'll take offline, please. This will be followed by lunch, so you can discuss during lunch.
You have said that steel industry uses chemicals. I am from steel industry. Steel industry uses minerals, not chemicals. It is because temperature. They use chemicals only for water treatment, so that equipment cooling water has to be of good quality. Otherwise, internal corrosion that takes place.
Sure.
Steel industry doesn't use much of chemicals. It is minerals only. And what actually is the water issues are, see, any industry, government has got strict guidelines, Ministry of Forest and Environment, and states pollution control boards, they give a lot of conditions. And even surface runoff water within the plant premises has to be treated. Effluent treatment plants are there in all the plants across the country. And they visit pollution control board officials, Ministry of Forest and Environment. They visit, they check everything in industry. The more problems are, like what she said, and all of us know it, this is the municipalities of the cities and towns, the sewerage system. The more health problems are because of that.
So we'll hear from you after lunch. There is an important announcement. We have a very interesting session coming up at 2:15. So we have discussed business, policies, technology, but in order to complete the loop, we need to actually collaborate with incubators who are bringing up new technologies in different fields. And IIT Bombay is one of those leaders. In fact, this technology convention, we have been much encouraged by IIT Bombay. So I would just briefly tell you the names. We will be basically joined by Professor Meena Chintamaneni, officiating Vice Chancellor, and from SVKMs, NMIMS. Then we will be joined by Professor and Head of Department Chemical Engineering, IIT Bombay, Mr. Rakesh Kumar, ICFI Group. Then we have Department of Electrical Engineering, IIT Bombay again. Then IIT Ropar. We will also be joined by Associate Professor of Industrial Engineering and Operations Research, IIT Bombay. And finally, we have the keynote address by Dr. Shashmit Patra. He is the Member of Parliament, Rajya Sabha. So please stay back. Today is a Saturday, so I'm sure you will have some time to spare and to network with them. I think you will be immensely benefited. May I have a count of people who would like to join the session, please? Roughly? Okay. So please get in touch with my colleague Pooja. She is there at the back. So now we close the session, and I would request Mr. Patni to kindly felicitate the esteemed speakers on the dais. It has been a very engaging panel. Dr. Michelle Ashkanani, who's joining us virtually, will have the memento sent to you.
Thank you so much.
ঠিক আছে তো স্যার, ভালো করেছি চকলেট। Now I would request Dr. Rajiv Singh, Director General, Indian Chamber of Commerce, to kindly felicitate Mr. Ankur Patni, Chairman, ICC National Expert Committee on Water, and Vice Chairman at Ion Exchange India Limited. Thank you very much, everyone, for joining us in this session. Would request everyone to please. So please join us for lunch, and then please come back to the same hall for the session. Thank you very much.